I want to talk about global variables considered harmful, because basically if you have some piece of code out here and you have a database and you pull data out into that code, you do some processing on it, you update it, what you have here is a giant persistent store of global data. And that global data, I'd like to tell you, is difficult to manage and difficult to work with. But anytime somebody in the computer field says considered harmful, what they're really referring to is Dijkstra's 1968 letter to the ACM go-tos, considered harmful. And that's Dijkstra, D-I-J-K-S-T-R-A. There's a lot of consonants in there. But if you go Google Dijkstra and go-tos considered harmful, you can go find the PDF. It is just a letter to the editor. It's only one page, but I'd like to give you some flavor of what he was talking about back then, because we live in a blessed era where you don't see go-tos used very often. They're still in some languages. They're still damned useful for some things. For some things, they are the best way to implement things. But in 1968, you were talking by and large about things like Fortran, and I worked on a Fortran 66 program that did a bunch of graphic stuff and topological modeling, and it was 3,600 lines of code that looked like this. Now you have to understand Fortran was done in two different fields, actually three fields. There was a label field, there was a code field, and there was a comment field. And all your code had to go in the code field, which means you had to space over 6, and the labels were all numeric. So you might have something that said, think of 3,000 lines of code with, I think it had 6 or 7 subroutines in it. If A would have had to have been an integer in this context, 15, 30, 301, or 310. And these are labels that it's going to jump to if it's less than, equal, or greater than. And in this context, if it just had A, that would be A compared to 0. And the next line might be if J. And J is not equal. Okay, and it didn't use operators, it used dots. And you'll notice that there are no spaces anywhere in this. Not equal to 22. 2180 310. And somewhere down in the code. Now, first of all, none of this was indented. It just went straight down. None of this was indented. Just thousands of lines of this kind of stuff. And then you'd get to, in no particular order, either 310. Whatever was going on at 310. And the code could fall in the top, or it could jump to this from someplace else, or it could loop by going around. And this was the only thing, was ifs and these computed go-tos. So when he's talking about considered harmful, this is what he's talking about. This kind of a nightmare pieces of code that you're supposed to go in and maintain or fix or do something to and sort out. Not our beautiful block structured with subroutines and functions and objects and interfaces and all these nice things for managing data. Well, this is for managing code, but it's also for managing your data and working on it constructively in smaller and smaller pieces. And then we go, wow, we've got this database, and the database is a giant pile of global data. And then there was the database, my goodness. So these giant piles of global data, okay, they are around. Okay, they are being used. We're updating them. We're trying to maintain them. We have constraints and data types and things like that to help us maintain integrity within the data itself so that you don't put bad data in. Because you're not just talking about bad data for today when your program is running. You're talking about bad data for 40 years from now when somebody's still trying to understand what is going on with that piece of data. So, go-tos considered harmful. Global data considered harmful. I spoke to a person not long ago about how global data compares to go-tos, and this is a person that was teaching at MIT in 1968. She's quite old, but she says, global data is just as harmful as as go-tos. So, there is this global data is a big deal and difficult. And what are we going to do about this? Well, we do some modeling. We do constraints. We do checks on that data. We build better programming languages, like I think Haskell is a big deal, functional programming languages, so that they have the initial state and they do some sort of transformation, and at the end they have an end state. But where does that state go? Well, it goes back into our database. One fashion or another. You could have a file, you could have data, but most of that is just going back into a database. And with all this data, it becomes difficult to maintain it. When I'm talking about difficult, one of those considerations in maintaining lots of data is that you have just out-and-out data rot. As in, you stored it, but it changed on its own in between, and later you came back to it, and it wasn't the same anymore. That's a consideration. What do we do about things like data rot? How do you get a production copy of that off into your testing system? Well, there are things that we can do these days that help tremendously with that kind of stuff. Not just we took a full backup and we restored this full backup. It takes 2 days to restore it, and we get to test with it for a while. But you can actually, if you are in control of the Linux system, there's a file system called BTRFS. And BTRFS, first of all, it can span multiple volumes. It can make duplicates of the data so that you don't just have one copy. It does checksums of the data so that if there is data rot, it can tell you and you can automatically switch to a backup copy of the same data. So it's high reliability. But it also has the ability to say, at a particular point in time, what I'd like to do is I'd like to make a shadow clone of the data. So I'm making this clone out here of an entire set of data that is frozen in time. It's called a snapshot. And you can go in Postgres and you can say, I'd like to start a database, tell BTRFS to do a snapshot and tell it, I'm done doing the database backup at this instant. And between those two, you can get it in under 1/10 of a second. So 1/10 of a second between those two and get a copy of your database that you can then sit here and run a new instance on, bring it up, and you can do a full database backup. You can do a cold database backup, as in just copy the files off to some other location and start a database. There's lots of things you can do with these snapshots. Now, these snapshots are not what you get if you just, do an Amazon Web Services instance. You're going to have to be much more in control of the hardware, the file system, the operating system, and all the details along the way. But if you want to do a database and maintain it that way and get these fast snapshots, that's a very useful thing. And also, it means that for something that's up 24/7, if I do a snapshot and then I do a backup of the snapshot, I can do that once an hour. I could do an incremental backup of the snapshot and have a database that literally I'm backing up every hour with the users never seeing that I even did a backup. Because the database out here running on this one doesn't quit when you do this. You tell it it's in backup mode, and instead of it writing stuff, it finishes writing, tells you it's ready to do a backup. And at that point, anything that changes, it just does it in memory and holds on to it until you tell it you're done with your backup. And 1/10 of a second later, you say, I'm done. Okay? And then it writes the stuff out. And the users never see that anything happened. So a backup system based on this in combination with somebody that wants to work with, Backup Manager in Postgres Backup Manager, which is the most common backup tool, and you bring up another database, then you use Backup Manager, and this works really amazingly well. But you do have to manage your own hardware. Now, there are other advantages to managing your own hardware. You may have a mixed set of hardware where you've got a bunch of spinning platters that are cheap for big stuff that isn't used very often, but you've got your hot tables, the ones that are used frequently, moved over to SSD storage, and you get some amazing performance, you get some cheap costs, you get some capabilities to do backups, and all of these things are important. Now, another thing that you got to think about in terms of this global data going off to a backup, and then we're going to use it in a test system, is not just privacy, but privacy and legal responsibility. The two kind of go together. I'd like to put it in the context of HIPAA, the healthcare privacy law. Suppose that your system over here is tracking people's heart monitors. And you've set it up so that you can do these fast backups, and your developers would like to have access to this data so that they can do testing for the next version. But in between doing this restore and giving it to them, you have to randomize, delete, encrypt, or something all of the private data. And if you don't do that, you will be in violation of HIPAA law. And that is a felony, subject to a $100,000 fine that you are personally responsible for, and up to 5 years in prison. Okay? So before you just go, oh, we'll just take a copy of the database and give it to them, you need to have an understanding of what's in there and what laws apply. HIPAA is the most restrictive, but there are federal laws about data privacy. There are presidential orders that have been around for a decade at least now, that came out a long time ago, okay, that are still in effect, having to do with how this data is used. There are privacy requirements now for some states if it has data that is biometric data in it, okay? And Facebook is facing a multi-billion-dollar fine from the state of Iowa for even collecting some of this data. So you've got to know your local laws as well as your federal laws and whether or not these things apply to your backup system. And when you do your backup, how much have you protected it? Is it on-site? What happens if they have a fire? Is it off-site? What happens if a third party can get to it? Did it get encrypted? How are you maintaining the keys? Can other people get to it? I mean, if you go on a vacation to Fiji, what is your backup plan in case the database goes down while you're in Fiji? And does somebody else have access to the encryption key so that they can restore a backup? Have they done it? Okay? Now, some things along the way to avoid, like the plague. Docker. Don't build production databases on Docker. I mean, Docker is fine for messing around with. The problem is that the database has an understanding of spinning platters, going around and around and around and timing, and the fact that data is actually updatable. And consequently, it wants to know that it has actually written it, and it needs to know that it can update data in place. Docker containers work on top of a file system that is on top of your file system in your system, and it is not an updatable file system. When it does updates, it does a copy and append, which means that if you use the Docker file system, your database is just going to grow over time and never shrink. Not only that, but the file system was never intended for this kind of a use, so it is really, really slow. And there is a company out there that I know of that converted off of Docker onto bare hardware to get some of these advantages. And that particular company saved about $100,000 a month in terms of hardware costs. That's $100,000 a month by moving away from Docker, and solved a bunch of problems. It also almost killed them as a company to do it. It was that bad a move. But they have survived, and yes, okay, $1 million a year because they got rid of Docker. Don't curse yourself with Docker from the beginning in production. Just don't put a database on it. Another reason not to use Docker for a database is, remember, by default, everything in Docker runs as the root unprivileged account. And you think about a database, and it has the capability of doing all sorts of things, like writing files on the system. And suddenly, your database can turn around and write a file that has passwords over the password file in your system, and somebody remotely can log into your system because they figured out a way to crack into some unsuspecting account in your database, and it's running as root. This is just bad mojo. Bad stuff. And I use Docker for lots of stuff, but I don't mess around with putting databases in it. Not in production. I use it in my test environments. Avoid running any significant database on Windows. And I think the Microsoft people just cringed in Washington when I said that, but I will give you an example. Windows runs with a thing called a working set memory model. The working set memory model is not the same kind of thing that you see in Mac OS, Linux, Unix, Solaris. But the working set says basically that anything that pops up some kind of a display on the screen is the one that gets the priority for the usage of the memory. The reason they did this is a long time ago. Windows 3.1, this was a critical feature to get it to work with any kind of performance. But that means that your server, if it produces an error and a dialog box pops up on this display, out of your server farm with 400 machines running with no computer monitor on any of them, okay, suddenly the database no longer gets memory priority and nobody knows why. It just slowed down. My best estimates on the difference between working set memory and virtual memory the way Linux does is it costs you somewhere between 10% and 15% performance. And you have this flaw. How bad is this flaw? The London Stock Exchange spent $100 million moving their stock exchange from running on Windows servers to Linux to solve this problem. That's how bad a flaw that is. So, yeah, you can do it. But it's not a good example. Not a good plan. Okay? Hosted systems for AWS for running databases, they tend to be expensive. They've got their own database systems that they run. They do all the backups for you. They do the maintenance. They're reliable. They're expensive. There are some times when it's a good idea, but be aware that it is a costly thing to do. And out of all of this, you need to not just have some ideas, you need to understand the costs and trade-offs. The biggest one is business people that tell you they want everything up 24/7, and they don't care about how much it costs until they find out how expensive it is to do a system like that. And then they go, and you say, can I get just 5 minutes a year when it isn't up and running? Okay, and that costs a lot less. That 5 minutes a year can be you having a stuff like this, being able to switch to a new thing, being able to upgrade from, version 13 of Postgres to version 14 once a year. And suddenly the costs drop dramatically. So, understand your trade-offs and costs. And experiment with your database and look at what the cost is. Because ultimately, the reason for using something like Postgres or NoSQL databases like Mongo is, where is my cost, when am I going to experience it, and how much is it going to cost? And a lot of times that cost can be quite large. We're not talking small amounts. And you need to understand the trade-offs. Other trade-offs. If I create indexes, it takes time and space to maintain those indexes when I do inserts, but I'm getting time and return on time when I do selects. Again, that kind of cost return, when is it justified? And the only way you can figure this out is you can try stuff and you can look at the comparative costs and measure it. You can't just say, well, this is always going to be the way we should do it. There is no such thing. But if you test it and you try it and you say, here's what my cost was, here's where it showed up, and here's how I'm going to look at optimization, the cost over time. So, other things you should know about being a person that works with database. Almost always you're on call, and the on-call is usually at night. If you don't do restores from your backups, you never know if they're going to work. So anybody that wants to have a reliable database over time, you should do restores maybe once a month. At least 4 times a year, you should restore the production database from a backup. If not more often. Even if you got it to work once, you should keep doing it, which means you need to have a system that you can restore from. I was doing some work down in Denver. This is some years ago. And I was about to set up a new business for something, and one of my customers from my existing business called me in the middle of the night and asked if I could help them with their database. We'd built a database product called AutoDBA. And I asked them what was going on, and their DBA was on vacation, okay? and their entire system was down. And I was talking to them for a while, and I came to the conclusion that they had hardware problems. And these people got really lucky, and not a little bit lucky, because 2 days before I had 2 servers delivered to my house, okay? And they were the same servers that they had in production. And I said to them, okay, I'm going to come down and I am going to lend you 2 computers, okay? And these were not little boxes. These were like $30,000 computers that I had sitting on my living room floor with my kids bumping into them. And I packed them up. I drove downtown in the middle of the night. I had a cold. I wasn't feeling good. And I got down there and we set up those servers. We hooked them up to their network. We configured them. We went to their backups. We managed to restore with only 1 call into Oracle to say, how do I get past this problem? And restore their database. And by 8 a.m. Monday morning, I was beat to a pulp. Okay? Because I worked all through the night and I wasn't feeling good to start off with. But I got their database up and their customers never noticed. And man, did they owe me some money for that little stunt. Okay? I mean, yeah, I've got spare computers I could show up. Okay? So yeah, sometimes people get lucky. Don't bank on your future being that kind of luck. And to this day, you know, I could probably go back to them and say, hey, you got any contract work you want me to do? And they go, yeah. Okay, because I didn't charge them for this, but man, they owe me. So there you go. Sometimes you just get lucky. And they did. They bought me 2 new computers, same models, everything, to replace the ones that suddenly they had just needed in the middle of the night. All right. That is global variables considered harmful, global data considered harmful, and, you know, why it is really important to have constraints and checks on your data, because this stuff is going to be around forever, and if you don't, it's going to burn you so bad eventually.